When it comes to tiled shower floors, a level perimeter has long been a highly desired design element as they result in a cleaner, more symmetrical look. Plus, it's easier to install the wall tiles when all the bottom cuts are the same. Except for ADA compliant showers, industry standards require shower floors to have a minimum constant slope of 2% and a maximum slope of 4%. This slope allows the water to drain properly without creating a slip hazard and makes the shower floor easier to tile. Let's look at the basics on how to determine the slope when building a shower floor. Step 1 is to find the longest measurement from the drain to a corner. In this case, it's 35 inches. Step 2 is to multiply this measurement by 2%. 35 multiplied by 0.02 means we have a minimum slope requirement of 0.7 inches. This is the slope between the furthest point and the drain. Step 3 is to find the shortest measurement from the drain to the center of a vertical surface. Here, it's 18 inches. Step 4, we take the slope measurement of 0.7 inches from our first calculation and divide it by the shortest measurement, which in this case yields our steepest slope of 3.9%. Since this resulting number is lower than 4%, you can have a level perimeter for your shower floor. There is a handy shortcut that will let you know right away if you can or can't have a level perimeter. That is, if the longest distance is less than or equal to twice the shortest distance, you can have a level perimeter. Since industry standards require a 2 to 4% slope, we are working with a 1 to 2 ratio. Once the longer distance is more than twice the shorter distance, a level perimeter isn't possible. So what do you do when you can't have a level perimeter and you still want one? The most obvious first solution is to move the drain to a more central location and run the calculations again. When this doesn't provide a solution, there are 3 other answers. Change the size or shape of the shower floor, add a second drain, or place a linear drain along the main axis of the shower, thus shortening the distance from the furthest wall to a drain. But all too often, none of these solutions will work, and you are left with having an unlevel perimeter due to several factors which are often in conflict with each other. The size of the shower, the shape of the shower, the location of the drain within the shower, the location of floor joists or structural steel, the location of rebar in reinforced slabs, the location of cables in post-tension slabs, and whether you're using a linear drain or a point drain. And if that weren't enough, an additional complication comes into play when there's a curbless shower and the perimeter across the entry threshold needs to be level with the main bathroom floor. If you find yourself in a situation where you can't have a level perimeter, here are some answers to help hide or minimize the visual aspects of that unlevel perimeter. 1 is to move the drain closer to the entry and have the perimeter of the rest of the shower rise along the shower walls. 2, place a linear drain across the entry with the remaining shower floor rising along the walls. 3, add pony walls to hide the rising shower floor. 4, use a glass panel at the edge of the shower floor to hide a descending shower floor. 5, changing a common shower bench into a floating bench as to increase the distance between the drain and a vertical surface. By now you're asking, when the site conditions won't allow for a level perimeter, just how far out of level will my perimeter need to be? I'll be using this custom foam shower base for a typical tub replacement as an example of how to determine the change in the perimeter where the width to length ratio of the shower floor is further away from being square and where the drain is offset to one side. We will be using the same method we did before by measuring the furthest distance to the drain center, calculating the slope, then comparing that to the shorter distance. Step 1 is to find the longest measurement from the drain to a corner. In this case, it's 52.5 inches. Step 2 is to multiply this measurement by 2%. 52.5 inches multiplied by 0.02 means we have a minimum slope requirement of 1.05 inches, which is right at 1 1/16. Step 3, we find the shortest measurement from the drain center to a vertical surface. Here is 10 inches. Step 4, take the slope measurement of 1.05 inches from your first calculation and divide it by the shortest measurement, which yields our steepest slope of 10.5%. As we can see here, because of the width to length ratio of the shower, combined with the drain location, it's not possible to have a level perimeter because we have exceeded the maximum 4% slope. To stay within the 4% maximum slope, we take the shortest distance of 10 inches and multiply it by 4%. This gives us the maximum perimeter height above the finished drain of 0.4 inches, or right at 3/8 of an inch. When converting to fractions, it's always better to err to the smaller fraction. Next, we subtract the short slope height of 0.4 inches from the long slope height of 1.05 inches, which equals 0.65 inches, or 11/16. This means when we meet the maximum 4% slope, the long perimeter sides slope down 11/16. The wet wall will have a level perimeter, and the opposite wall will have a level perimeter. Because it's a continuous bowl shape, from this corner to the drain, the slope is 2%. From the side wall to the drain, the slope is 3.1%. UPC code allows for the slope to exceed 4% only when the drain is 10 inches or less from a vertical surface. But in this instance, where the long walls are 16 inches away from the center of the drain, the slope in this area cannot exceed 4%, and is why the perimeter on this wall must tilt downwards. By following these basic measurements, your shower floor will be within industry standards, it'll drain properly, will feel the flattest underfoot, will be easier to tile, safe to walk on, and provide lasting results. For more information, consult your local plumbing authority, the TCNA Handbook, and the NTCA Reference Manual. Thanks for watching, and happy tiling.